I just shot the video about how to use Genome, the Python package, to analyze Japanese. If you just want to know how to extract the words and their parts of speech, feel free to jump to the installation section and this part near the end of this video. But if you want to get a better understanding on this package, better watch till the end. Let's go. Open up the browser and search Genome Python. Welcome to Genome's documentation English. At this moment, the latest version is 0.5.0. Your Python's version has to be 3.7 or above. Basically, if you install Python now, you should be installing Python 3.11 or above, and you shouldn't have any problem. Pip install Genome. Here, I'm installing Genome to an existing virtual environment. As I said before, in case you've messed up something, it will only affect that virtual environment, but not anything to your system. If you don't like it, simply get rid of the environment and start over with a new environment. That's the buffer zone for errors. Go to the environment that will be using Genome. The environment's name might be different on your side. I installed it in the G drive testinf. Then scripts activate python-m pip install Genome. Wait for a while. Done. Start with an idle, the place where you go. I'll use a tokenizer. What is a tokenizer? It simply takes in a sentence and gets split into a list of items, usually in the form of a single word or a class. Since we usually use NLTK or PyJIT, that kind of language processing tools, we won't just import one tokenizer. So here, from genome.tokenizer, import tokenizer as JT. That's just like what it does here. Usually, I won't use T for the Japanese tokenizer, but name it TokJ to indicate Japanese tokenizer. It's a tokenizer object JT. That's what exactly it does here. Now we can use this tokenizer object to get a list of words. Here we just create a variable source text to store the string of a Japanese sentence. Let's say we want to split it into Mate, Kudasai, Apollo, and Sang. Let's turn this sentence into a token. What is a token? It divides this sentence into different words. Each word has its parts of speech. Just name it ST sentence token. Turn this sentence to a token. Okay, the token is TOKJ because we name it TOKJ above. Token.tokenize. This action inside the tokenize function takes in the source text, which is this string. Press enter and you'll get a tokenized object. But when you print it out, you won't see the result. So how to print it? TOKJ.tokenize, then source text. For each item, turn it into a string. Result, yep, there we go. Each item within the tokenized object list is now turned into a string. That's what you see here. Alright, let's say assign end result to join the new line with the list result here, like this. Print end result should be, there we go. It's not perfect. Here you see it splits Mate into Ma and Te. Kudasai is a word, which means please, thanks, something like that. Apollo, a person's name, so it's a noun. You see, this one, each word or vocab is followed by its parts of speech. The whole thing is treated as a tokenized object. Let's see how many items inside the result object. Simply len result. There are 7 items. What are the 7 items? The first one, the second one, the third one, the fourth, the fifth, the sixth, and the last one, 7th. But remember, they're not named from 1 to 7. Like we mentioned in the previous video, what is the first item? 0. The second item is 1, and so on. This numbering convention is called index. The first item's index is 0. The second item's index is 1. The third item's index is 2, and so on. The index of the last item is 6, provided there are 7 items in the list. Print the last item, which is 6. You see here, the full stop. What we want is stacking up the words and their parts of speech. How to do it? We can't just use string directly. Now for I in this tokj.tokenize, take in the source text, then here in the display area, set it to I.part of speech. Okay, got it. Print it out. Yep. Let's assign it to PS. Display PS. Let's see if we can extract the first item. PS0.split, and the separator is comma. Then 0, and get the first verb item. Okay. So result for I in talk.tokenize, source text I.service. Result. Then we'll get a list of each word from the sentence. Let's apply this for loop for the parts of speech. PS punctuation. For I in talk.tokenize, I.part of speech. With each part of speech split by comma, then select the first one, which is 0. Okay, got it. Now we have a list of words and its corresponding list of parts of speech. That's the result we want to get. Simply tabulate, import tabulate as TB. There are 2 lists, result and this one, PS, parts of speech. So inside the tabulate object, the first property is tabular data, which is a list. You put in list 1, list 2, list 3, or whatever number of lists. Now we only have 2 lists. Okay, then comma. The next thing I want to set is table format, which is table FMT. Just put in TSV. The list on top is PS. The bottom list is result. Print delete. Okay, then you see every word or vocab within the sentence and its associated parts of speech are stacked together. That's about it. Ciao.